Assalamualaikum. I am Siti Zainab Muhammad from Team Treasure, and the assigned topic for us is about the 11th chapter, the Enterprise Resource Planning Systems. This video is actually the third part of chapter 11, and in here we will discuss all about data warehousing. Now let us begin by defining what is a data warehouse. A data warehouse is a relational or multidimensional database that may consume hundreds of gigabytes or even terabytes of disk storage. So we all know what is warehouse. Para siyang storage room, right? So a data warehouse is like a storage room ng information about sa company, about their products, their customers, and clients, and others. So, example nito is the Suki card or yung mga SM Advantage card, Watson's card, and etc. So, where do the companies use this? So, before having this, ina-apply ito ng mga customers, right? How binibigyan nila yung basic info like yung name, gender, ethnicity, location, and others. So, through this, nakakakuha yung company ng info about sa mga customers nila at tinatago nila yon sa malaking warehouse called the database warehouse and use the data for their benefit like para sa strategic planning nila. So, data warehouse is one of the fastest growing IT issues for business today. Not surprisingly, data warehousing functionality is being incorporated into all leading ERP systems. So when the data warehouse is organized for a single department or function, it is often called a data mart. So itong data mart is like a mini version. Same lang sila ng data warehouse. Yung sa size lang sila nag-differ kasi yung data warehouse consume hundreds of gigabytes or minsan terabytes of disk storage. So while yung data mart may only have tens of gigabytes of data. Let us move on to the data warehousing versus the data mining. So, the process of data warehousing involves extracting, converting, and standardizing an organization's operational data from the enterprise resource planning and legacy systems and loading it into the central archive called the data warehouse. So once loaded na siya into the warehouse, yung data ay accessible via various query and analysis tools that are used for data mining. So, data mining is the process of selecting, exploring, and modeling large amounts of data to uncover relationships and global patterns that exist in large databases but are hidden among the vast number of facts. Like yung example natin kanina, yung Suki card or yung mga customers card, after nilang makuha yung info about their customers, ginagamit nila yon for their strategic planning. For example, aalamin nila which age mabenta yung product nila, and in that way, mas makafocus sila sa promotion doon sa specific category ng customer nila. Again, data warehouse is yun yung collection of data about companies, clients, customers, suppliers, competitor, and others. So, once the entity has this big file of data, pumipili sila doon sa data to figure out the trends in the data. So, yun yung tinatawag nila na data mining. Most organizations implement a data warehouse as part of a strategic IT initiative that involves an ERP system. Implementing a successful data warehouse involves installing a process for gathering data on an ongoing basis, organizing it into meaningful information, and delivering it for evaluation. So the data warehousing process has the following essential stages. First, modeling data for the data warehouse. So we will learn the process of designing the schema of the detailed and summarized info of data warehouse. Ito yung normalized data, i-consolidate into the normalized data. Then, second, the extracting data from operational databases. This is yung getting the data. Then, third stage is yung cleansing extracted data. Nire-repair yung data from errors and other mga kamalian doon sa data. Then, transforming data into the warehouse model. So, tina-transforming data to make it useful. Then, the last stage, loading the data into the data warehouse database. So, dito na sinisave yung data into the warehouse. So, let us further discuss about the first stage, modeling data for the data warehouse. Sa Chapter 8, we have learned na yung importance ng data normalization para ma-eliminate yung 3 serious anomalies, yung update, insertion, and deletion anomalies. Normalizing data in an operational database is necessary to efficiently and accurately reflect the dynamic interactions among the entities. Data attributes are constantly updated. So, new attributes are added and obsolete attributes are deleted. Even though a fully normalized database yields the flexible model needed for supporting multiple users in an operational environment, it would add unnecessary complexity and performance inefficiency to the operation of a data warehouse. So kahit after normalizing operational data, kahit updated na yung data na yon, may mga unnecessary pa rin na complexity. The warehouse consists of the normalized data. Dahil sa vast size ng data warehouse, such inefficiency can be devastating. A three-way join between tables in a large data warehouse may take an unacceptably long time to complete and may be unnecessary. In the data warehouse model, the relationship among attributes does not change because historical data are static in nature. Nothing is gained by constructing normalized tables with dynamic links. For example, in an operational database system, product X may be an element of work in process in Department A this month and part of Department B's work in process next month. In a properly normalized data model, it would be incorrect to include Department A's work in process data as part of a sales order table that records an order for product X. Only the product item number would be included in the sales order table as a foreign key linking to the product table. Relational theory would call for a join or link between the sales order table and product table to determine the product's production status, in example, which department the product is currently in, and other attributes of the product. From an operational perspective, complying with relational theory is important because the relation changes as the product moves through different departments over time. Relational theory does not apply to a data warehousing system because the sales order or product relation is stable. So wherever possible thereof, normalized tables pertaining to selected events may be consolidated into denormalized tables. So makikita natin dito sa figure how sales order data are reduced to a single denormalized sales order table for storage in a data warehouse system. So, yun. In this stage, kailangan i-condense yung data bago ipasok sa data warehouse, just like sa nakikita natin sa figures sa baba. So the next stage is extracting data from operational databases. Data extraction is the process of collecting data from operational databases, flat files, archives, and external data sources. So here is the stage where we get data from the original database papasok sa data warehouse. Operational databases typically need to be out of service when data extraction occurs para maiwasan ang data inconsistencies. Because of their large size and the need for a speedy transfer to minimize the downtime, little or no conversion of data occurs at this point. So a technique called change data capture can dramatically reduce the extraction time by capturing only newly modified data. The extraction software compares the current operational database with an image of the data taken at the last transfer of data to the warehouse. Only the data that have changed in the interim are captured. Extracting snapshots versus stabilized data. Transaction data stored in the operational database go through several stages as economic events unfold. For example, a sales transaction first undergoes credit approval, then the product is shipped, then billing occurs, and finally, payment is received. Each of these events changes the state of the transaction in associated accounts such as inventory, accounts receivable, and cash. Isa sa key factor ng isa sa feature ng data warehouse is that dapat yung data doon are in non-volatile, meaning hindi pa bago-bago or stable state. Typically, transaction data are loaded into the warehouse only when the activity on them has been completed. Potentially important relationships between entities may, however, be absent from data that are captured in this stable state. For example, information about canceled sales orders will probably not be reflected among the sales orders that have been shipped and paid for before they are placed in the warehouse. One way to reflect these dynamics is to extract the operations data in slices of time. So, hahatiin yung data. These slices provide snapshots of business activity. For example, decision makers may want to observe sales transactions approved, shipped, billed, and paid at various points in time, along with snapshots of inventory levels at each state. Such data may be useful in depicting trends in the average time taken to approve, credit, or ship goods that might help explain lost sales. The third stage of data warehouse processing is cleansing extracted data. Data cleansing involves filtering out or repairing invalid data prior to being stored in the warehouse. So, after ma-extract yung data, ngayon, lilinisin natin siya or ipopolish by filtering it out and repairing before ilalagay sa warehouse. Operational data are dirty for many reasons. Marami kasing possible na errors na need munang ayusin. Clerical, data entry, and computer program errors can create illogical data such as negative inventory, quantities, misspelled names, and blank field. Data cleansing also involves transforming data into standard business terms with standard values. Data are often combined from multiple systems that are use slightly different spellings to represent common terms such as cost or cost ID or cost number. For example, kasi minsan hindi consistent yung term na ginagamit. So, some operational system may use entirely different terms to refer to the same entity. So, yon. Dito sa stage na to, inaayos yun at pinapaisa na yung term. For example, a bank customer with a certificate of deposit and an outstanding loan may be called a lender by one system and a borrower by another system. So, magkaiba sila ng ginamit na term. The source application may use cryptic or difficult to understand terms for a number of reasons. For example, some older legacy systems were designed at the time when programming rules placed severe restrictions on naming and formatting data attributes. Also, a commercial application may assign attribute names that are too generic for the needs of the data warehouse user. Businesses that purchase commercial data such as competitive performance information or market surveys need to extract the data from whatever format the external source provides and reorganize them according to the conventions used in the data warehouse. During the cleansing process, the attributes taken from multiple systems need to be transformed into uniform, therefore, standard business terms. This tends to be an expensive and labor-intensive activity, but one that is critical in establishing data integrity in the warehouse. So, in the next slide, we see a figure of illustration of the role of data cleansing in building and maintaining a data warehouse. So here, um, before ipapasok yung data from operational database and yung galing din sa order entry system or purchases system, kinu-cleanse muna sila. So, they undergo first sa data cleansing process and then, after that, isa-summarize sila and ipapasok sa data warehouse. The next stage or the second to the last stage is transforming data into the warehouse model. So, dito tinatransform yung data to make it useful. A data warehouse is composed of both detail and summary data. To improve efficiency, data can be transformed into summary views before they are loaded into the warehouse. So in this stage, we transform the data to make it useful. Kinukuha yung data and make it into the same format, found names or titles. So in short, sinasummarize siya or ina-update para mas maging pakipakinabang bago isi-save doon sa warehouse. For example, many decision makers may need to see product sales, or they may need to see product sales figures summarized weekly, monthly, quarterly, or annually. It may not be practical to summarize information from detailed data every time the user needs it. A data warehouse that contains the most frequently requested summary views of data can reduce the amount of processing time during analysis. Balikan natin yung figure kanina. We see the creation of summary views over time. These are typically created and around business entities such as customers, products, and suppliers. Unlike operational views, which are virtual in nature with underlying base tables, data warehouse views are physical tables. Most OLAP software will, however, permit the user to construct virtual views from detailed data when one does not already exist. A data warehouse will often provide multiple summary views based on the same detailed data such as customers or products. For example, several different summary views may be generated from sale order detail data. This may include summaries by product, customer, and region. From such views, an analyst can drill down into the underlying detailed data. Many business problems require a review of detailed data to fully evaluate a trend, pattern, or anomaly exhibited in the summarized report. Also, a single anomaly in detailed data may manifest itself differently in different summary views. Lastly, loading the data into the data warehouse database. After mag-extract, mag-cleanse at mag-transform yung data, isi-save na yung data sa warehouse. Most organizations have found that data warehousing success requires that the data warehouse be created and maintained separately from operational or transaction processing databases. So there are these reasons. First is the internal efficiency. One reason for a separate data warehouse is that the structural and operational requirements of transaction processing and data mining systems are fundamentally different, making it impractical to keep both operational or current and archived data in the same database. So, processing systems need a data structure that supports performance, whereas data mining systems need data organized in a manner that permits broad examination and detection of underlying trends. Next, integration of legacy systems. The continued influence of legacy systems is another reason that the data warehouse needs to be independent of operations. A remarkably large number of business applications continue to run in the mainframe environment of the 1970s. By some estimates, more than 70% of business data for large corporations still resides in the mainframe environment. The data structures these systems employ are often incompatible with the architectures of modern data mining tools. Hence, the transaction data that are stored in navigational databases and virtual storage access method or VSAM systems often end up in the large tape libraries that are isolated from the decision process. A separate data warehouse provides a venue for integrating the data from legacy and contemporary systems into a common structure that supports entity-wide analysis. Let us proceed to the decisions supported by the data warehouse. So yung mga info sa data warehouse, gagamitin yan ng iba't ibang end users from different department. Some decisions that a data warehouse supports are not fundamentally different from those that traditional databases support. Some users of the data warehouse need routine reports based on traditional queries. When standard reports can be anticipated in advance, they can be provided automatically as a periodic product. Automatic generation of standard information reduces access activity against the data warehouse and will improve its efficiency in dealing with more esoteric needs. The drill down capability is a useful data analysis technique associated with data mining. Drill down analysis begins with the summary views of data described previously. When anomalies or interesting trends are observed, the user drills down to lower level views and ultimately into the underlying detailed data. We can see in this table the applications of data mining. So, maa-apply siya sa iba't ibang business field like banking or investments, healthcare and medical insurance, and then sa marketing. In the field of banking or investments, it detects patterns of fraudulent credit card use. It identifies loyal customers and predict those likely to change their credit card affiliation. It examines historical market data to determine investor stock trading rules, predict credit card spending of key customer groups, and also identify correlations between different financial indicators. Sa healthcare and medical insurance naman, it predicts office visits from historical analysis of historical patient behavior. Data mining also identify successful and economical medical therapies for different illnesses. Identify which medical procedures tend to be claimed together and then predict which customers will buy new policies, identify behavior patterns associated with high-risk customers, and identify indicators of fraudulent behavior. In the field of marketing, data mining helps identify buying patterns based on historical customer data. It identifies relationships among customer demographic data and predict response to various forms of marketing and promotion campaigns.